another topic of thermal physics, and again there is one more numerical about the specific latent heat. And now we have a very special question, and we are given that we have a funnel, and in this funnel we are keeping the crushed ice, right? So we have a funnel with crushed ice. It's not a solid pieces of ice. Crushed ice is there. So let me just put the crushed ice. This is the crushed ice, right? So I put a beaker just here so that we can collect the mass of the melted ice. Means we can collect the water in the beaker. So this is my beaker, right? So what is happening? This funnel is at room temperature. So because of the room temperature, the crushed ice that will start melting, and we will collect the mass of the melted ice. All right. So mass of melted ice for 2 minutes, only for 2 minutes, only for 2 minutes. This activity, right, means the heating due to the surrounding, right? The surrounding is just heating the ice, and the mass of the melted ice that will be collected, but only for 2 minutes, right? So let me take the mass collected M1, that is equal to 2.1 gram, right? This 2.1 gram, this is due to the heat from the surrounding, right? Then we put another apparatus here, that is the heater. So I put the heater inside this funnel, and this is my heater. The power of the heater is 40 watt. So I just switch on the heater, right? Switch on the heater only for 2 minutes. Again, for T is equal to 2 minutes. So again, the new mass collected in the beaker, right? So this is the new mass collected in the beaker. Now that new mass, let me take, that is M2, that is 16.3 gram. The new mass collected, right? So guys, can you tell me the new mass collected is only due to heater, or it is not only due to heater, means any other thing is also there which is contributing for 16.3 gram? Yes, Jessica, this M2 is only due to heater because the crushed ice and then heater, and the heater is only for 2 minutes. The power of the heater is 40 watt, and the mass collected in the beaker is 16.3 gram now. So my question is that this M2, which is 16.3 gram, this is specifically due to heater or not? No, this is not due to heater. You see, the surrounding is also working, right? The surrounding is also working. So this M2 is equal to 16.3 gram. This is both due to heat from the heater and heat from the surrounding. Getting my point? But I am interested in the mass which is only due to heater. Understanding my point? Which is only due to heater. So how we can get? If I subtract this mass from this mass, because this mass is heating from the surrounding, right? Understanding my point? This mass is due to heating from the surrounding. So if I subtract the mass collected in the beaker due to surrounding from this mass, then I will get the mass collected in the beaker only due to the heater, right? So now mass collected in the beaker only due to heat from heater. heat from heater, which is a 40-watt heater. So M2 minus M1, that will give the mass M. So this mass M will be the mass only due to heat from the heater. So 16.3 gram minus 2.1 gram, so we will get 14.2 gram. Okay, so 14.2 gram is the mass collected in the beaker only due to heater, right? And yesterday I told you that heater is supplying heat energy Q, right? And the mass collected in the beaker, now the final mass is 14.2 gram, right? This is final mass M. So Q is giving this M, right? Q, heat from the heater, which is Q, and this is giving a mass M in the beaker, which is 14.2 gram. So now if I divide Q by M, right? Q by M, heat supplied to the water and mass collected in the beaker, then what I will get? Latent heat of fusion, right? So now latent heat of fusion, latent heat of fusion means LF. LF, latent heat of fusion, LF, that will be equal to Q divided by M, right? Q, heat from the heater and the mass collected in the beaker, right? So Q is equal to, how we can find out Q, right? So Q we can find out, that is power into time, right? So Q is equal to, power is 40 watt and time is 2 minutes, multiply by 60, so that we can take the SI units. So Q will be equal to 4800, and this is in joule, 4800 joule, right? So this is 4800 joule divided by M, which is 14.2 gram. So LF, after doing the calculation, that will be equal to 338.02 joule per gram. That will be the latent heat of fusion, right? So we have a funnel, and in the funnel we are placing the crushed ice. This experiment is about the crushed ice. It's not about the solid pieces of ice. If we do with the solid pieces of ice, then result may be different, right? Because to melt the solid and for the environment and for the heater means in that case the collected mass, that may be different, right? Because to crush the solid means to liquefy the solid piece of ice, it will take more time, right? But this is the crushed ice. So in the first case, only surrounding is melting, this mass M1, and heater plus surrounding, they are giving this mass 16.3 gram. And if we want to calculate the mass collected in the beaker only due to the heater, means M2 minus M1, M2 minus M1, so we will get 14.2 gram mass collected in the beaker only due to the heat from the heater, right? And now how to calculate the heat supplied, how to calculate Q, heat supplied by the heater? Simple formula, just multiply power with time, you will get, right? Take the SI units, right? And then finally latent heat, just divide Q by M, right? Q, what we are giving to the ice and actually what we are getting from the ice, right? We are giving Q to the ice, right? And we are getting M from the ice. So Q divided by M, so that will be equal to this, right? So this is the first part of this activity, first part. In the second part, if we place this whole apparatus in an insulator, this whole apparatus means the funnel as well as the beaker, everything, if this everything, whole apparatus is kept inside a perfect insulator, not a perfect but appreciably good insulator, right? So whole apparatus is kept, whole apparatus is kept inside an insulator. What will happen? What will happen in that case? So if we place the Hall apparatus inside the insulator, then the effect of surrounding that will be cancelled, right? So it means surrounding will not do anything with this melted ice. So M1 that will be cancelled, right? No mass collected in the beaker due to surrounding. That will be cancelled because of the insulator, right? So only mass collected in the beaker, right? That will be, suppose a heater, right? Assume a heater is melting the ice, and collected mass in the beaker M is equal to 16.3 gram. Again, we assume the same mass. We are just assuming. It may be less or it may be more, right? But we are assuming the same mass is collected, right? So now the latent heat, now LF, right? Same heater, everything is same, just we are placing it inside the insulator. So Q is same, but there is change in M. So what is Q? Again the same Q, 4,800, right? Means again this activity is done for 2 minutes, means heater is there only for 2 minutes, right? So M now in this case again 16.3 gram, this is joule, this is gram. So now latent rate of fusion that will be equal to, SI just do the calculation, 4,800 joule divided by 16.3 gram. I think it will now decrease. Latent rate of fusion, now it will decrease. What is the value? Yeah. 294.47. 294.47 joule per gram. So you see the denominator is increased, denominator is more as compared to the previous case. In the previous case the denominator was 14.2, right? So our value was 338. So now you see, if we place the Hall apparatus inside the insulator, the latent of fusion that will increase, right? So this is the standard value of latent heat of fusion for ice. But if we place, right, if we place the ice, means if we cut off the ice from the surrounding, right, just cut off the ice from the surrounding, then the effect of surrounding that will not be there. And finally in that case, if we assume the heater is of same watt and it is allowed to melt the ice again for 2 minutes now, and assume again the collected mass is 16.3 gram, that it is 16.3 gram in this case, that will be less than the previous case. Understanding my point? Because that 16.3 gram that was due to heater plus surrounding, but I assume in here, right, this is again 16 point, but if you see actually it will be less than 16.3 gram because we are just cancelling the effect of surrounding, but I assume the same. So as per my assumptions, the latent heat of fusion that is more in this case. Okay.